that might have thrown some of you for the calculation. It says there are 2 legs. So what should we do with 2 legs? Yeah, I think we have to multiply by 2. Because the flea has 2 legs. I suppose if it had 100 legs, it could jump higher. So how do we find h? So that 2, that just cancels with that. So h is going to be equal to kx squared over mg. This is because it has 2 legs. That's why I put the 2 in there. So h is kx squared over mg. So k is this number where they put the wrong units in. It's supposed to be this number here, 28. Is supposed to be 28 newtons per meter. It doesn't make sense otherwise. X, how far does the flea compress his leg? Well, it's not very much, is it? It says 0.1 millimeters. So it's not much, but fleas are pretty small, so 0.1. What's a millimeter? I want to do it all in meters, so what's a millimeter?
1,000 meter.
Yeah, so can I say 10 to the negative 3 meters? And I'm going to square that. And I want to divide by m. What's the mass of the flea? Mass is 0.52 milligrams. So I need to do it in kilograms because you've got to do everything in SI units. If you want the units to work out, you've got to get everything in SI units. That means MKS. Meters, kilograms, seconds. So how many kilograms is a milligram? Right, it's 10 to the negative 6, isn't it? Because a milligram is 10 to the negative 3 of a gram, and then a gram is 10 to the negative 3 of a kilogram. So this is actually 10 to the negative 6 of a kilogram. So 10 to the negative 6 is 10 to the negative 3 of a gram, but 10 to the negative 6 of a kilogram, and then times 9.81. Don't forget to put brackets around everything. I mean, I would definitely put brackets around on my calculator around the numerator and around the denominator. You want to make sure you get the calculation with the correct order of operations. So I can see that the 10 to the negative 6 is cancel actually. 10 to the negative 6. So that must be about 3, and this is about 5. It's close to 1, isn't it? A bit less than 1. Denominator is about 5. The numerator is about, oh no, it's 0.1 squared. No, it's late, it must be about 0.001. The 10 to the negative 6 is cancelled. But this is, don't forget to square this. You have to square the 0.1, so 0.01, 0.28. Yeah, it's quite a bit less than 1. What will the units be? So the unit, we've got Newton per meter times meters squared in the numerator. And the denominator I've got, what's kilograms times meters per second squared? Is a Newton, is it? Kilograms times meters per second squared is newtons. So it looks like the units are just going to be meters. So what do we get? It's pretty small, I think. Meters. And also, that's a nasty little trick. You see, they put the centimeters. But what do we get for this? Let's just do this first. 0.28 over about 5. It's about 0.05, something like that. It's 0.0 something.
So
0.055 meters, right. So I was, at first I might have been tempted to put that. Of course on an exam, if you put 0.055, that would be okay. If you put meters. As long as you wrote meters, that would be okay. However, nasty little thing they did, they put centimeters in the box there. You get, is that what? It's a mean little. So we should just get rid of this part. 5.5. Why is it going to something like, yeah. Yeah, I mean, to ask you to give the answer in centimetres is just because I suppose they feel that's the appropriate unit for a flea. And that's pretty big, isn't it? If you think about it, the flea is jumping 5.5 centimetres. That's about 500 times, I don't know, 0.1 millimetres. And it's a lot, many times 5 centimetres is about 50 millimetres. So it's about 500 times the amount it's compressing its leg. So that's really a very great height compared with its size. Okay, so let's look at something else. Yeah, other question. You know, I'm happy to go over other things, but I need some. Yes.
Chapter 9, Part 2, Question 8.
So this is about collisions.
Yeah.
Okay, Chapter 9, Part 2.
Question 8.
Chapter 9, Part 2. Question 8. Is that says 9.36?
Yeah.
Okay, so this is about a car. Yeah, I think you can do these things where you click practice, can't you? Can you do those? So you figure that I hope by now it's a bit late, but if you've already done the homework, you can click it into practice and do it again. Okay, so it says a car is stopped at an intersection, and it's rear-ended by a truck. Do you think that this is about elastic or inelastic collision? So what do you think? Do you think it's elastic or inelastic? Do you think it's elastic? Why? Why do you think that? But it says so. So, and the clue here is it says the car is in neutral with the brakes off. So if the car, if you keep the brakes on, if you're sitting in the intersection with your brakes on and you're rear-ended, it's more likely that you'll stick together, right? If you've got your brakes on and the parking brake on, and somebody hits you, you're more likely to move together. But if you've got the brakes off, you don't have the brake on, and it's in neutral, it's more likely to be a free elastic collision. So anyway, the question says elastic, so that's what we'll do. So we can use the two equations. Now does it want, so it says a truck hits the car. So which is the M1? So M1 is the truck, isn't it? Is that right? The truck is moving and it hits the car. So the truck is moving and it hits the car. The car is stopped, right? Car is stopped and it's rear-ended by a truck. So if the car is in neutral, what's the final speed of the truck? So what are they asking me for? We call that, what do we call that? V1 or V2?
V2. Oh, no, V1.
Yeah, because the object that's moving we call number 1. The object that it hits we call number 2. So this is before. After the collision, I'm going to assume that the truck moves off with a speed V1 and the car moves off with a speed V2. It might have used V1 and prime and V2 prime. I think it called it V1 prime and V1 and V2 prime. Let me take the conservation of energy away now. So the truck comes in with an initial speed, we called it V1 or V0, doesn't matter what you call it, I'm going to call it just V, and the car is at rest, V equals 0. And these questions are all about objects that are moving into something that's at rest. I don't think we did anything where they were both moving. So the truck hits the car was at rest. Afterwards, the truck moves off with a speed V1, the car moves off with a speed V2. So what's V1? So V1, I can use this formula here, M1 minus M2 over M1 plus M2, which can sometimes be negative. Do you think it's going to be negative now in this question? So on this slide they're calling it V1. I'm just going to call it V. I want to just keep it simple and call it V, or V0. naught. So what's m1 minus m2 in this question? Well, the numbers that I've got are this one. The truck is at 1780 minus 710. So I've got 1780 minus 710. They're all in kilograms. So I don't even need to write kilograms because they're going to cancel over 1780 plus 710. So do we get a positive answer?
Yes.
That's essentially like a ratio, and we're going to multiply that by 14.5 meters per second. I didn't bother to write kilograms because we got kilograms divided by kilograms. So what does that all become?
Wait, I thought V naught was 0.
Well, no, V naught is, the car is 0. I'm calling V naught, I'm calling the speed of the truck. I know it might have called it, I know this is, different notation is used. The slide has called it V1. But I just want to, it's the initial speed of the object that's moving. You can call it whatever you want, the object that's moving. So the truck is the one that's moving, 14.5 meters per second. So that's the only velocity that we've got to work with. So what does that work out to be? And then I'm going to work out the speed of the car. I assume, does it ask us for that as well? So what's the formula for that? So I'll give you these formulas. You don't have to have these memorized. What's the speed of the car? The speed of the car is 2m1 over m1 plus m2. Always multiplied by the speed of the object that was moving. So the speed of the car that gets hit is 2m1 over m1 plus m2 multiplied by the speed of the object that was moving. So it's going to be 2 times 1780